Hello everyone. So today we are solving another question of JEE Advanced 2021. So this was from the topic of rotation motion, and this question is very much very useful to clear all the concepts of the rotation motion. So let's see how we can approach this. So first read the question. So it says that there is a horizontal force applied at the center of the mass of cylinder object of mass m and radius r perpendicular to its axis as shown in the figure. The coefficient of friction is mu, center of mass has acceleration a. The acceleration due to gravity is g, given that object rolls without slipping. So this is one of the most important part given in any of the rotational dynamics question, that the rolling is happening without the slipping. So which of the following statements are correct? We have to tell them. So we will first draw the free body diagram of our given cylinder. So it will be like this. First, let's make a circle. So at the center, there will be a force in this direction, F, and in the downward direction, there will be gravity, that is mg. In the upward direction, it will face a normal force N, and at the part which touches the bottom, it will experience a force of friction here. So let's read our first condition. What it says, that the coefficient of friction between them is mu, and the center of mass has an acceleration a. So what we can write from here, first equation, if we do all the sigma x, not sigma x, sigma force x is equal to ma, cos F equal to ma. So net force should give acceleration equal to a. So F minus F should be equal to ma. I have this equation is clear from here. And let's read our third part, given that the object rolls without slipping. So this condition is only true when its acceleration, that is a, should be equal to r alpha, where alpha is nothing but angular acceleration. Angular acceleration. Okay. So this is the condition for rolling without slipping. And we have to keep this in mind throughout the question. So I think a few more things are required. So let's see what our first option says. For the same and the value of A does not depend on whether the cylinder is solid or hollow. Okay, so let's find what A should be. Let's suppose if we find torque about this point O, we'll define this point as O. If we find torque about this direction, so the only force which will apply torque is friction. So tau is equal to F times this distance is nothing but the radius R from here to here. Okay, so F into R. And we know that torque is nothing but it is equal to I alpha. This is Newton's law of motion. Fr is equal to I alpha. So to do this, we can write F into R. I depends upon whether it is a hollow cylinder or a solid cylinder. So let's take I alpha. Okay. Now we have to find for A. What is A? A is nothing but R alpha. So we can substitute alpha as equal to A by R. If we put it here, F into R is equal to I times A by R. Okay. So F R square by I is equal to A. So we can clearly say that the acceleration is completely dependent upon what the moment of inertia is. And I have told you earlier that moment of inertia will be different for both hollow and solid cylinder. It means our option A is incorrect because it says that it does not depend. So highlighting this part, we can say that the option A is incorrect. And for a solid cylinder, the maximum value of A is 2 mu g. Okay, so let's see what it is. If we know that our acceleration is nothing but F into R square by I. So it is given if solid cylinder, what is the moment of inertia for a solid cylinder? It is nothing but mr square by 2. It is same for disk as well as solid cylinder. A should be equal to F into R square by mr square. Okay. So A is equal to F by m. Now if it is been asked for the maximum value of A, so what can be the maximum value of friction here? So to calculate this, okay, so wait, I have made a mistake here because I have written mr square by 2, but I haven't multiplied here 2. So it is nothing but F into 2. So 2F by m. So what can be the maximum friction be? So maximum friction, as we know during the rolling motion without slipping, it here applies a static friction. Static friction, not the kinetic friction. And if you know about friction very much, then you must know that the static friction has a property that it applies within a range, not a fixed value. So it varies from 0 to some maximum value. And what is the maximum value? It is nothing but mu n. And what is the maximum value of n? It is mg. So hence we know that the maximum value of friction that it can apply, it is nothing but mu mg. So A is equal to mu. A is less than or equal to mu mg into 2 by m if we cancel. So A should be less than or equal to mu 2 mu g. Hence our option B is obviously correct because it has mentioned that the maximum value of A is 2 mu g, which is correct. The magnitude of the frictional force of the object due to ground is always mu mg. Just now I told you that the static friction has a property that it is applied on a body within some range. It is never fixed that it will apply on the only at the maximum value. That is the property of kinetic friction. So whenever it will attain the pure rotation, so it will be some value less than the maximum, and it is not fixed that it will be always equal to mu mg. Hence our option C is incorrect. Now given for a thin walled hollow cylinder, A is equal to F by 2m. So what is a thin walled hollow cylinder? So we just found that A is nothing but equal to F into R square by I. Okay. I think, yeah. So A is equal to F into R square by I. So if we write I for hollow cylinder, it will be equal to F into R square by mr square. Okay. Mr square, cancelling R square. A is equal to F by m. So again, if I put here, I have to find A only. So I should write F in the terms of A. So F in the terms of A, it is ma is equal to F. If I put it here, so F minus ma is equal to ma. Hence I get F is equal to 2 ma and A is equal to F by 2m. Hence our option D is also correct. Hence only B and D options are correct here. So let me write answer B and D. Thank you so much.